In this video, we're going to talk about the period of a sinusoidal wave or graph. All right, so a periodic function, it's not just sine and cosine that are actually periodic. There's a lot of different types of things that are periodic, but they're things that repeat at a regular interval. And the period is just like the smallest length of interval where you just keep repeating. All right, so this is the definition, not super important for you to know. It's just where this name period is coming from. All right, something that repeats repeatedly. All right, so what is the period of sine and cosine? All right, well, when is sine and cosine going to repeat? Well, as I kind of increase my angles, I'm getting all these different values. I'm not repeating. I get the same values, but now they're negative. I get the same values, but now they're in reverse, so that doesn't really make sense. But once I get all the way around the circle, then I start getting all the same values again. All right, so I repeat my sine and cosine values every time I do a full lap around the circle, which is 2 pi. So every 2 pi, my sine and cosine graph begin repeating, and that's why when we're graphing it, we kind of just graph a single wave, even though it keeps going forever. Because if we have a single wave, we know it just keeps repeating. So 2 pi is that kind of first cycle, and my graph just keeps repeating every 2 pi after that. All right, so what would happen if we had a function like sine of 2x? All right, what do you think would happen? Well, this 2, it means I'm doubling the angle. So if I put in pi over 6, I'd actually double it and end up at pi over 3. If I put in pi over 2, I'd actually double it and end up at pi. So this 2 is just making me double whatever angle I put in. If I put in pi, I would actually double it and end up at 2 pi. So what's going to happen is, because I'm doubling the angle, I start repeating myself twice as fast. So instead of repeating myself every 2 pi, I'm going to repeat myself every pi in terms of what I'm plugging in. Sine itself is still repeating every 2 pi, but based on what I'm plugging in, it's going to repeat every pi. All right, so by changing the number in the inside of the parentheses here, I can change how often my graph is going to start repeating. All right, and before we get to this side, let's look at a little animation. All right, so here we have sine in red, our original sine graph, and sine of bx. So this number inside the parentheses next to x is going to change the period. So watch what happens when I make b a bigger number. Like we just saw with 2, my period should get smaller. My graph should repeat more often. So as I slide this up to 2, you can see this blue graph, sine of 2x, now it repeats more often. It does this kind of up and down quicker than the original red graph did up and down. If I keep making this number bigger, my graph repeats more and more often. So now for 4, you can see it does this up and down really quick compared to my red graph, which does the up and down really slow. Just keep going. You can see just my graph repeats faster and faster. As I get up to 10, all right, I have this really quick repeat of my sine graph versus this really slow, drawn out one for the original sine graph. So as I make this number bigger, my graph just repeats more often. As I make the number smaller, go back down to the starting point of 1. And you kind of see like this scrunches it up. So you can imagine as I go smaller, it's going to stretch it out. All right, so now I can go down to like a half. And now you can see that my original sine graph repeats faster than this new sine graph, which takes a long time. And keep going more and more down. All right, now at 0.1, look how long it takes this blue graph to repeat itself all the way over to like here, 230 pi over 11 or something like that. But my original sine graph is repeating much more quickly. So smaller numbers, it's going to take longer to repeat itself. Bigger numbers, they're going to repeat itself much more quickly. All right, we're not going to talk about what happens when you make it negative. It's not really too crazy, but we're just going to focus on the positive numbers. Small, it's going to take a long time to repeat itself. Big, it's going to repeat itself quite quickly. And how exactly is it going to repeat itself? There's just a nice little formula. The exact amount that this new graph is going to repeat itself is you take the original period 2 pi and just divide it by that b. I guess I should make this a capital B. All right. So if I divide 2 pi by whatever this number is, that's going to give me this. So if I go back to this slide here, the period of this is 2 pi divided by this number, and that's pi. That's exactly what we said the period should be. All right, so now the problem is actually graphing this thing, and we're going to graph it a little bit different than it showed up here. So if we were to like keep the scale the same for our original sine graph, All right, this is just our normal sine graph. If we wanted to keep the scale the same, if we wanted to graph sine of 2x, we'd have to do a lot of little waves. If we wanted to graph sine of 4x, we'd have to do a lot more waves. So instead of like using the same scale and drawing a lot of waves, what we're gonna do is kind of change our scale and instead like zoom in just on the part we care about, this one first thing. All right, so a little confusing, but instead of having to draw a lot of waves, we still just wanna draw one wave, all right, to make it a little bit simpler. But to do that, we have to change the scale of our x-axis. We no longer are gonna have 2 pi here, because if we kept that value at 2 pi, we saw that's here. That means I'd have to draw a lot of waves, which is tedious, especially if I was doing like sine of 20. All right, you don't have to draw this by hand. Instead, I would like to zoom in just on the part I care about here, all right, and do that. All right, so how am I gonna do that? Well, instead of having 2 pi here, this is my normal sine graph, would look like this. And it would repeat every 2 pi. So now I want to replace this with how often this new graph is going to repeat. So this new graph is going to repeat. We saw the little formula is 2 pi over b. B is the number next to the x. And that's pi over 2. So now if I zoom in on this new graph, it's going to repeat every pi over 2. So now instead of kind of my right side of my graph being all the way over here, let's make it the exact same thing, make it 4x. All right, so instead of my graph being all the way over here at 2 pi, and I can see all of these waves of sine of 4x, I'm shrinking it down to just be pi over 2, so I can just see this first wave. All right, so I've kind of shrunken my graph down so I only see one of the waves, just because it's easier to draw. All right, so that's the most important thing, is just knowing this value is going to change. Even though your graph looks the same, because you've changed your scale, it's actually not the same graph. Right. And then how do I get these other tick marks? There's 2 ways you could do it. The first way is you could just do 3 pi over 2 over 4, just 3 pi over 2 times 1/4, is 3 pi over 8. All right, so that's going to be this tick mark now. The pi over 2 is going to be divided by 4, which was this one. I don't know why. Let's make sure I actually do it in order. The next tick mark was 2 pi. No, pi over 4. That simplifies enough. That's just pi over 4. And the last one was pi over 2 over 4. Just pi over 2 times 1/4. Just pi over 8. All right, so I took all my original x values and just divided them all by the same b value, and they all change accordingly. All right, so that's my new scale, and this is my final graph. Again, it looks the exact same as my original sine graph. The only difference is I changed my scale. Instead of this being 2 pi, it's pi over 2. All right, cosine of 1/2 of x. All right, so my original cosine graph would look like this. Missed that a little bit. Let's just redo it so it's not that bad. There we go. That's better. All right, so this is my original cosine graph, and normally I'd put a 2 pi here and then my other quadrants. But instead, my period, how often this graph repeats, is 2 pi over 1/2. Dividing by 1/2 is the same as multiplying by 2 over 1, and that's 4 pi. So this is going to be 4 pi. That's the repeat of my cosine graph, this cosine graph. And now I want to get the other one. So here's the other way you can do it. You could, again, go 3 pi over 2 divided by 1/2 to get this tick mark, pi divided by 1/2 to get this tick mark, pi over 2 divided by 1/2 to get this tick mark. So you can do that every single time. The other way that I tend to do it is this is the 4th tick mark, is 4 pi. I could find the 2nd tick mark. Well, the 2nd tick mark is half a far away. So if I divide this number by 2, that'll give me the 2nd tick mark. It's halfway back to the x-axis. And now if I look at the 2nd tick mark, if I go halfway back to the x-axis, I'm just dividing this by 2 again to get pi. And I'm kind of had to skip this one because I went halfway back. So I kind of had to skip this one. But now that I know each tick mark is pi, I can do 1 tick mark, 2 tick marks, 3 tick marks to know that this is 3 pi. So this 1 times 3. All right, that one I think confuses students a little bit. For me, it's a lot quicker. Just divide this by 2, divide that by 2, multiply that by 3. The other alternative is take my original quadrant breaks and just divide them all by this number. So as long as you're comfortable simplifying all these fractions and things, that'll also get you your 4 tick marks. All right, so this one, sine of pi x, graph sine first. All right, sine starts at 0. All right, I'm not going to put a number here yet because I want to figure out my period, which is 2 pi over b. In this case, b is pi, it's the number next to the x. And the pi's cancel and I just get 2. So the number I'm going to put here is 2. And again, it's up to you how you figure out the other 3 tick marks. What I would do is 2 cut in half is 1. 1 cut in half is a half. 1 half 3 times is 3 halves. But you could also take those original ones and divide them all by pi. Either way, in this case, would be pretty quick. All right, but this is my final graph. All right, so here's one for you to try your own. Cosine of 2x. Go ahead and graph this one and try it on your own. All right, and this is what I came up with. So my original cosine graph, the only difference is now the period. This right-hand side is pi. I personally cut it in half, so divide by 2 again, multiply by 3. Right. But again, however you get these tick marks, I'm fine with. Just making sure the most important one, you're definitely not going to pass the skill check if you don't get that one right. But the kind of weird thing with this lesson is the graphs look the same if you kind of ignore this part. It looks the same as the original one. The only difference is you're kind of zooming into your graph and using a different x scale. All right, so I apologize for this one being so long, but it tends to be a little bit more confusing about exactly why our graphs look the same even though they're different. The important step to remember is the number inside the parentheses affects the period. There's a nice formula for figuring out that far right tick mark is just taking the original sine and cosine period, 2 pi, and dividing it by that number on the inside. And all that really changes on your graph is the x-axis. So again, if we look at this one, if I ignore the x-axis, it looks like my normal cosine graph. But by having these different values, I've kind of represented that I've zoomed in and I'm looking at just a single cycle of cosine. All right, so sorry for the long video, but hopefully now you can figure out how to graph these new types of transformations.